In this lecture, we're going to go over some of the C# fundamentals to prepare you for this course. Because our expectations for this course are that you do already have some familiarity with basic programming concepts and have previously done at least some coding in Unity. So this video will really act as a quick reminder of some key programming concepts and also as a reference for what you should already know before diving into the rest of the course. Now, I will be moving quite fast, so you can think of this very much as a crash course, but if you find any of the concepts in the video too advanced or you get a little bit lost, then do consider checking out at least the first few projects from one of our complete C# Unity developer courses, either the 2D or 3D course, to get yourself up to speed. So first up, let's have a look at where we can get some help if we get stuck with any of the general syntax. Well, first of all, we have the Unity documentation at docs.unity3d.com. So that's a great resource for any of the Unity specific tools and features. And then for more generic things, we have the Microsoft C# documentation at docs.microsoft.com. So that's where you'll be able to find a lot more information on general syntax for C#. Now, when it comes to C# programming, the first thing to get to grips with is the overall script structure. So at its very top level, we have namespaces, and namespaces can be used to collect together a bunch of different classes. Inside our classes, we then have various methods that do things for our program, and inside each method, we have statements which perform all of the logic. So with this structure, remember that classes can be nested inside namespaces. Classes generally contain a collection of methods, and methods contain statements and logic. In Unity specifically, we tend to use two different types of inherited class. First of all, we have the all-powerful mono behavior. This derives from the base Unity object class, and it allows us to add various components to an object in the Unity inspector. So whenever we want to add something to our game in the hierarchy, we're generally going to be using some kind of mono behavior. And our mono behavior contains a lot of common methods, such as our start and update method, as well as many others. The other option for a Unity class in most cases is going to be a scriptable object. A scriptable object also derives from the base Unity object class, but it has a very different function. Scriptable objects generally just act as data containers for storing data on disk, and they cannot directly be attached to a game object in our scene. So whenever we want to use a scriptable object, we generally have to pass that data into a mono behavior to get it into the rest of our game. Next, let's look at methods. And a method, sometimes known as a function, executes blocks of code. A method must have a return type. We generally write our name of our method in Pascal case, so the first letter is capitalized and then every subsequent word is also capitalized. And we generally name them using verbs. So as an example, we might have the method do something or get a thing. And unlike these examples, it's best to be as descriptive as possible. To use a method, we need to declare it inside of a class. We call it from inside another method, so methods call methods. And in Unity's case, this generally comes from things like the awake and the start method to get things rolling. Next, let's go through our variables. And a variable acts as a container to store information. These are generally written in camel case, so the first letter is lowercase and then subsequent words are capitalized. Each variable will have a name, and it's good to make these names as descriptive as possible for what the variable is holding. It will contain some amount of data and is of a particular type. And some common types for variables include things like strings, integers, floats, bools, game objects, things like that. So as an example, here we have an integer variable called hit point, and this is storing a value of 20. So hit points here is our name. 20 is the data that it's containing, and it's of type int or integer. Next, let's look at scope, and in particular, variable scope. So variable scope determines what other parts of our code and our program has access to it. Variable scope can be controlled with keywords and by nesting them inside other code blocks. So we might decide to label our variables with the keyword public or private to say whether it's only accessible within the class itself in the case of being private, or globally accessible with the public keyword. And we can also have some measure of control by using the Unity attributes like serialized field, which will change the variable's visibility to the Unity inspector without changing their scope in the code. So as serialized field as an example, we could place this on a private variable, and at this point, the variable would not be accessible to other scripts in our game, but it would be visible in the inspector so that we can set values without having to code them in directly. So here's an example of some basic code. At the top here, we have our namespace, which in this case is GameDevTV. But above this, we also have some imported namespaces, and we import the namespaces using the using keyword. And at the bare minimum in Unity, we generally have the using Unity engine namespace, because this includes things like our mono behaviors. Next, we have our class declaration. So in this case, we've got a class named new behavior script, and this inherits from our mono behavior. So if we wanted to use a scriptable object instead, we could change this mono behavior inheritance to scriptable object, and this would change the behavior of the class as a whole. Next in our code, we have a variable being declared. This is a private integer called myInt, and it stores the data value of 2. And we've also got a serialized field attribute to allow us to modify this in the Unity inspector. Finally, we have some methods. So we have our start and update methods here. And if you recall, start is called when the game object is created, and update is called every frame. So with the general structure of our script covered, now let's look at some of the things we can do inside of our code blocks. Let's start with selection statements and begin with if and else if, because these really are the bread and butter of most of our functions that we write. These if and else if statements control whether code is run based on some conditional statement. So we might write if some condition, then we have a code block. So this might be if a variable is less than some other variable, or if some condition is true. And our if statement is perfect if we just want a single conditional statement. But if we want to do other things based on other conditions in case this one fails, we can then write our else block at the bottom. And not written here, but we also have the else if, which kind of slots in between our if and our else statement. Next, let's look at our switch statements. And these control flow by matching an expression to a given case. So we might have a switch statement which is looking at a particular value, and we can then have various cases that will be executed based on that value. So that's our selection statements, and now let's look at our iteration statements. We'll start with the simple for loop, because again, this is really one of the bread and butter iteration statements that we use. For loops will repeat a statement until some condition is met, and importantly, they keep count of the number of iterations they've gone through. And because of this, we usually use these to repeat actions a set number of times. Here's a quick example of a for loop. And notice that the declaration here is split into 3 parts, all separated with a semicolon. At the start, we have our initializer, so our int I equals 0. In the middle, we have our condition, so I is less than some value. And finally, we have our iterator. So in this case, it's I++, meaning that every loop around our for loop will increase I by 1. Our next iteration statement is our for each loop, and this is very similar to a for loop. However, the syntax is slightly different, and we tend to use for each loops to loop through entire collections of objects. So as an example, we might have something like this for each transform child in transform, which in Unity parlance will take a transform from an object and loop through all the children in its hierarchy. With our for and for each loop out of the way, now let's look at the while loop. And a while loop again repeats a statement until some exit condition is met. But unlike a for loop, it's a lot easier to get into an infinite loop, which can make it run indefinitely and crash your programs. So always proceed with caution when coding up a while loop. Related to the while loop is the do while loop, which isn't used quite as often, but it is still very useful in certain circumstances, because it's very similar to a while loop, but it always runs at least once. But just like a while loop, we can also run it indefinitely. So as an example of a do while loop, we have a do statement, which is the code block we want to run at least once. But then, while some condition is true, it will repeat that statement until our exit condition is met. And with that, I think we've covered our main iteration statements. So now let's look onto jump statements. And jump statements are pretty much used to transfer control from one part of our program to another. The most common jump statement is the return statement, which allows us to quit out of a method. Next, we have break, which stops the current loop or switch statement and is great for when we need to loop through things a certain number of times, but we want to stop when we've found the thing we're looking for. We can use a break statement to cut that loop short and save ourselves some processing cycles in completing the rest of the loop unnecessarily. Another great one is the continue statement, which will break out of the current iteration of a loop, but not break out of the loop entirely. Finally, let's look at collections. So just like how variables contain data, collections contain elements which in themselves contain data. So one way of looking at a collection is really as a box of boxes. Elements are given an index number within that collection, and remember that counting always starts at 0. So if we look at this simple representation of a collection here, we can see that the very first element in our collection has an index number of 0. The last element has an index of 4, and there are a total of 5 elements within our collection. Now, two of the most common collections that you should already be familiar with is the array, which is an immutable collection of a fixed size. So if we look at this simple snippet, we have an array of integers denoted by the brackets after the int type. Our array is called myArray, and it's equal to a new array of integers with a size of 3. So it's going to have 3 elements in this array. The other collection to be aware of before starting the course is going to be the list, which is a mutable collection with a variable size. And again, if we look at a code snippet, the declaration is slightly different. Here we have to declare a list of type int called myList. And because we don't have to give it a size, we can just initialize an empty list by creating a new list of type ints and then leaving some empty parentheses at the end there. So hopefully that crash course was a good reminder of all the things you already knew, but here are a final few useful reminders. Remember that time.deltaTime records the duration of the last frame of our game, and this is often used to make our code frame rate independent. So whenever you see us multiplying things by time.deltaTime in update or fixed update, our aim is to decouple our code's execution from the frame rate of our game. We also have to be aware of the script execution order to control the order in which our methods are called. So it's worth remembering, or at least recapping, some of the basic execution events. So in Unity, we have awake called before start when a game object is initialized. And then every update, we have the update method being called. And on a separate physics update, we have the fixed update loop. Now, while the Unity methods do happen in a fixed order, there's no guarantees of the order in which classes are called, unless of course you explicitly set it in the Unity editor. So if you have multiple classes interacting with each other, you need to be mindful of when each one may be created, and that order is not necessarily fixed. So something that may work in your particular environment may suddenly start to exhibit some bugs when other people on different machines get hold of your code. As a general rule of thumb to help eliminate these problems though, we tend to try and find components in awake, so this is where we're initializing everything, and then we use our components from the start method onwards. So I hope this very rapid crash course through the fundamentals of C# was helpful. I appreciate that I did go incredibly quickly through a lot of this material, and that's because you really should be familiar with everything presented in here before embarking on the rest of the course, because a lot of these things will not be explained in any great detail going forward. If you did find that you struggled to keep up, then again, I would strongly recommend checking out either our complete C# Unity Developer 2D or 3D courses, And then, once you're up to speed with your programming knowledge, you can come back to this course and continue on to the next lecture.